Hi everyone, we are from Group 3. I'm Risi and my teammates are Pavithra, Adilah and Irfan. The topic will be presented today is application of microbial technology used in bioremediation of urban polluted river, a case study of Chengnan River in China. As you can see in this slide, this is the article chosen for our presentation. This study has two purposes. One is to propose a more advanced, reliable and affordable new technology to restore urban polluted rivers into pristine quality levels. The second purpose is to promote water quality by directly adding into the river the microbial agents that were independently developed for the specific pollutants in order to verify whether the new ideas on the selection are suitable. Moving on in this paper, first thing addressed is the shortage of fresh water resources. This is due to the deterioration of water quality that makes the river body black and smelly from the increase in population and industrial activity. Second is the river contamination increased due to the discharge of untreated wastewater, including industrial wastewater, agricultural pollution, domestic sewage, and the fragmentation of aquatic ecosystems. Third is the proportion of the Chengnan River length decrease where the length is reduced to.
In this study, Chengnan River was chosen for the monitoring of microbial treatment on polluted river. Chengnan River is an urban river which runs through the main city of Pukao District, China, with high population and high building density. The sewage and production waste are directly discharged into the river, which causes the pollutants to be deposited, therefore making the river water to become black and the water quality to deteriorate. The river is categorized as inferior grade 5, which is the lowest level in the China environmental quality standards for surface water. The concentration of ammonia, nitrogen, total phosphorus, and COD exceeds the standard levels, which makes it extremely unsuitable for any purpose and in need of dire treatment. The significant method which were used to improve the river water quality is by introducing an microbial agent, which is HRRPE3. It consists of various types of microorganisms, including bacillus, yeast, enzymes, and many more. The characteristic of the microbial agent is that it can withstand extreme cold, have high enzymatic activity, and most importantly, it can efficiently degrade and absorb ammonia, nitrogen, nitrate, and also have great effects on other water quality parameters such as TP and COD. The microbial accelerating agent, which is made up of a variety of enzymes and vitamins, is also used to provide nutrition for the microorganisms. This helps to stimulate the activity of microbial agents. So the methodology of this study is firstly to prepare the product, then monitoring of the water quality. After that, two methods of water quality indices evaluation were used, which are Nemero Pollution Index and also the Fuzzy Comprehensive Evaluation. The figure shows the main channel of Chengnan River. It was monitored by sections which are F to A and showing the upstream to the downstream of the Chengnan River. The water quality parameters involved in the monitoring were dissolved oxygen, ammonia, nitrogen, total phosphorus, and also the chemical oxygen demand, COD. For the first water quality indices evaluation, the Nemero Pollution Index method were used. Nemero Pollution Index are commonly used for water quality evaluation as it is a simple process and can achieve highly relevant evaluation results. So, by comparing the calculated Nemero Pollution Index with the Standard Pollution Index classification, as in Table 1, the water quality classification of Chengnan River can be determined. For the second method, the Fuzzy Comprehensive Evaluation method were used. This method transfers qualitative evaluation to quantitative. So we can determine the water quality type by calculation of membership degree. The ultimate goal of the study is to improve the water quality by changing the ammonium nitrogen values from grade 5 to grade 4 in just 1 month. The significant results that can be seen from the study is where all the single factor water quality, including DO, NH3N, TP, and COD concentrations, were all seen to improve after the microbial treatment. Referring to the figure 3, we can see that after the treatment, DO has improved with rates up to 30%, and then the removal rates of NH3N were also up to 20%. And moreover, the removal rates of COD were also improved with up to 38%, causing all the river sections to drop below 40 milligrams per liter, which is much smaller than before the treatment. Next is the analysis at section A, which is the downstream part of Chengnan River. The concentration of NH3N is relatively low after the microbial treatment, causing the water quality to be enhanced by at least 2 levels. This proves that the microbial technology in heavily polluted river was very successful. The analysis Nemero index before treatment was 2.7, and according to the classification of Nemero index, it is considered as moderate pollution. However, after the microbial treatment, the Nemero index reduced to 1.9, which is categorized as light pollution. This means that there is an improvement by 1 rank on the water quality of the river. Similar patterns can be seen for the analysis by Fuzzy Comprehensive Evaluation Index. So before the treatment, the degree of membership to inferior grade 5 is always the highest, and it also shows an upward trend from section F to A. However, after treating with microbial agents, the degree of membership to inferior grade 5 shows a downward trend along the river. And furthermore, section A shows a degree of membership to grade 4, which shows preliminary success of microbial technology on polluted.
The striking thing about the article, specifically on the findings, is the chosen microbial agent used, which has a few great functionality. The microbial agent can effectively degrade and absorb ammonia, nitrogen, nitrite, and nitrate, and improve the efficiency of nitrification and denitrification. More surprising than this is the fact that this compound can actually remove ammonia nitrogen and also has a comprehensive effect on other parameters of water quality such as dissolved oxygen, total phosphorus, and chemical oxygen demand. After the treatment with microbial remediation technology, this ammonia nitrogen, COD, and total phosphorus decreases along the river. Moving on to the next slide, the striking thing about this study that we found was on the usage of microbial technology. Before I explain further on the microbial technology, there are actually 3 types of methods to restore the water quality of polluted rivers. The first one is physical methods such as artificial aeration and mechanical algae removal, which are basic and traditional methods that focus on treating symptoms but ignore the root causes of the pollution to some degree. Therefore, pollutants are not removed from the water body effectively. Next is the chemical method, which includes chemical oxidation and chemical algae removal. This method aimed at removing target pollutants such as suspended solids and dissolved phosphorus and nitrogen, besides improving the transparency of water. However, it is inevitable that secondary pollution is produced, thus hidden dangers for the ecosystem remain. The third approach comprises biological ecological method, including microbial technology, plant purification, artificial wetland, and biofilm technology, which are all environmentally friendly and aimed at enhancing the self-purification capacity of the river and restoring its ecosystem. Among all these methods, microbial technology stands out for its advantages: high efficient degradation ability, low energy consumption, no secondary pollution, simple technical operation, long-term viability, and absence of need for additional constructions. Thus, from this paper, the Chengnan River was treated with microbial remediation technology, and the results indicates that the bioremediation technology of directly adding microbial agent mainly aimed for the degradation of ammonia nitrogen, which can eliminate the black order phenomenon of the river and improve the water quality.
Hi, lastly, it's me Irfan. There is some additional information that you can't find in this article. which is another option that we can use, such as riverbank filtration. Riverbank filtration is a physical method where it still needs to further study, but it has been applied in Russia as alternative for their drinking water supply treatment. This method depends on the inorganic and organic pollutant in the river that can affect the removal efficiency. In this slide, we can use another method, which is an organic method called as phytoremediation. Using phytoremediation, we can improvise the method to become floating treatment wetland, where microphyte has been added to increase the removal efficiency instead of using only water plant. This method can decrease a large number of major pollutants, and it is a sustainable nature method for water restoration. I think that's all from our group. Thank you for your time and attention, and please have a nice day.